How you doing? Let's take a look at how to do factor trees and the concept of prime numbers. Let's jump in. We're going to make a factor tree for 24. So I'm just going to copy 24 down here and let's give it a try. We just make branches and we write numbers that get multiplied together to make 24. These numbers are called factors. For example, 12 times 2. And then we keep going. 12 can also break into 2 times 6. And you can stop here, but I like to bring them all down. So we've got all the factors in the bottom row. This can keep going. I'm going to bring the 2 down. The 6 can factor into 2 and 3. And the 2 brings down here as well. So that is one factor tree finished. There is actually more than one way to do a factor tree, but the answers at the bottom should never change no matter what the number. For example, if I do this again, and instead of 12 times 2, I do 3 times 8. Bringing this down, 3. 8 is 4 times 2. Keep going, bring that 3 down, and the 4 becomes 2 times 2. And bring this 2 down, we end up with the same numbers at the bottom. Just to illustrate more, I could have also started with, instead of 12 times 2 or 3 times 8, I could have done 4 times 6. Bringing that down and continuing that on, 4 breaks into 2 and 2, 6 breaks into 3 and 2. So as you can see, I've done 3 different factor trees here, but they've all ended up at the same place. 3 2's and a 3, 3 2's and a 3, 3 2's and a 3. This illustrates a very important idea in mathematics called the fundamental theorem of arithmetic. It basically says that when drawing a factor tree for a number, even though there may be different ways to do it, the numbers that end up at the bottom will always be exactly the same. I just want to talk a little bit more about what a factor is. A factor is a number that can evenly divide into a number. For example, the factors of 24, any number you can see here on the board is actually a factor of 24. 2, 3, 6, 12, 4, 8. I think I've listed them all there, and even 24. 24 is a factor of itself. Any number is always a factor of itself. While we're talking about factors, there are 2 types of numbers or factors you could see in a factor tree. One is called a composite number. A composite number is a number that can be factored or broken up into 2 numbers that are different from the starting number. For example, 14 is composite because it breaks into 2 new different numbers. Which of those numbers on the whiteboard are composite? 24 is composite. It breaks into 4 times 6, which are both different to 24. Same as 4, it breaks up into 2 different numbers that are different from 4. 6 is also composite. 8 is composite. 12 is composite, and 24 itself is composite. It breaks up into 2 new numbers. The other type of number you can see up here is called a prime number. Prime numbers are the dead ends of a factor tree. They're the numbers that end without going anywhere else. In other words, they don't factor into 2 new different numbers, only itself and 1. For example, 3. 3 does factor into 3 and 1, but 3 and 1 are not 2 new numbers. So we say 3 can't have a factor tree. And 3 is prime. Which of those numbers on the whiteboard are prime? 3 and 2. And that's it. Let's start a list of all the prime numbers. So 2 and 3 must be the first 2. Very important question. Why do we not include 1 as a prime number? Well, have you seen any 1s on those factor trees on the whiteboard? Nope, I haven't. Not a 1 in sight anywhere. That's one way to think of it. But the main reason is because mathematics textbooks have defined it that way. So always remember that on Earth, the first prime number is 2. Let's try another one. 70. A factor tree for 70. Let's do it. 70 can break up into 10 times 7. 7 can't break up anymore. 10 can break up further. 10 can break up into 2 times 5. There we go, a factor tree for 70. Here we have a couple more prime numbers, 7 and 5. They must be the next 2. So let's add them to our list. And yet another one, a factor tree for 29. Let's give it a shot. 29 can factor into 29 times 1. I don't think so. 29 does not factor into 2 new different numbers. 29 has no factor tree. So 29 is a prime number. Let's do one more to finish it off. 66, a factor tree for 66. Doesn't sound like a very lucky number. 66 is 6 11s. Can this go any further? Yes, 6 can factor into 3 times 2. And I'll bring the 11 down. It's just the way I like to do it. I like to see all the prime numbers on the bottom row. You can leave it up there, but I find myself, I forget it sometimes. So I like to list them all down in the bottom row. So there are our prime factors for 66. 3, 2, and 11. And this gives us the next prime number, 11. And that gives us our 5th prime number. Your turn now. Let's see if you can make factor trees for these little babies. One of these is a prime number in itself and has no factor tree. Which one? One of these factor trees will give you the next prime number for our list. What is it? And remember we found out that 29 is also a prime number? I remember. Let's add it to our list. And it turns out that there is a total of 4 other prime numbers between 11 and 29. Can you figure out what they are? And while we're here, what's the biggest prime number that you can think of? Share your answers in the comments, and thanks for watching.